everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations. So let's get going. Problem: solve d square plus d plus 1 into y equals to 1 plus sin x whole square. Firstly, let's find order and degree of the given differential equation. Identify the highest derivative. Here d square is the highest derivative, so our order will be 2. And the highest power of the highest derivative is our degree. Degree is 1. Or just write the given differential equation as d square y plus dy plus 1 into y equals to 1 plus sin x whole square. We know that d is a differential operator, which is d by dx. D square is d square by dx square. Then we can write d square y as d square y by dx square and dy as dy by dx plus y equals to 1 plus sin x whole square. Now identify the highest derivative. Here d square y by dx square is the highest derivative, so our order will be 2. And the highest power of the highest derivative is our degree. Degree is 1, right? Coming to the problem, we are given a differential equation which is in operator form. Given differential equation d square plus d plus 1 into y equals to 1 plus sin x whole square, which is in operator form. F of d into y equals to q, where f of d equals to d square plus d plus 1 and q equals to 1 plus sin x whole square. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function and yp is particular integral. We'll find yc using roots of auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by taking RHS to 0, the non-homogeneous becomes homogeneous. F of d into y equals to 0. Okay, homogeneous equation of the non-homogeneous equation. And we'll find yp using 1 by f of d into q. So let's find yc using the auxiliary equation firstly. The auxiliary equation of homogeneous equation is f of m equals to 0, where f of m equals to, we have f of d, which is equals to d square plus d plus 1. Let's replace d by m, so that we'll get f of m equals to m square plus m plus 1. Then auxiliary equation becomes m square plus m plus 1 equals to 0. Now, by comparing this equation with quadratic equation, we'll get values of a, b, c, and then using quadratic formula, we can find the required roots. Right? Now, quotient of a is 1. Quotient of m square is a equals to 1. Quotient of m, b, is 1. And constant c equals to 1. Now let's use quadratic formula. Minus b plus or minus square root of b square minus 4ac by 2a is equals to minus for b1 plus or minus square root of b square 1 minus 4ac by 2a, which is equals to minus 1 plus or minus square root of 1 minus 4 into 1 into 1 is 4 by 2 into 1, 2, which is equals to minus 1 plus or minus square root of 1 minus 4 is minus 3 by 2, which is equals to minus 1 plus or minus, you can write square root of minus 3 as square root of 1, minus 1 into 3 by 2, which is equals to minus 1 plus or minus, split square root of minus 1 into 3 as square root of minus 1 into square root of 3 by 2. We know that square root of minus 1 is I. So let's replace the square root of minus 1 by I, then we'll get minus 1 plus or minus I root 3 by 2, which is equals to minus 1 by 2 plus or minus I into root 3 by 2, right? So we got complex conjugate roots. Therefore, m equals to minus 1 by 2 plus or minus I into root 3 by 2 are the roots of our auxiliary equation, which are complex conjugate. If a plus ib is a complex number, then its conjugate is a minus ib. If a minus ib is a complex number, then its conjugate is a plus ib. If we have complex conjugate roots, a pair of complex conjugate roots, then we can write yc as e power ax into one constant into cos bx plus the other constant into sin bx. Right? Now, let's write the complementary function using this formula. Just compare our roots with the formula, that is m equals to a plus or minus ib. Then for a equals to minus 1 by 2 and for b equals to root 3 by 2, we can write the complementary function. Y is equals to e power minus 1 by 2 into x into 1 constant into cos for b equals to root 3 by 2 into x plus the other constant into sine for b root 3 by 2 into x, which is equals to e power minus 1 by 2 into x is minus x by 2 into c1 cos root 3 by 2 into x is x root 3 by 2 plus c2 sine root 3 by 2 into x is x into root 3 by 2. So this is the required complementary function. Now let's find particular integral. We can find particular integral using yp equals to 1 by f of d into q. We have f of d squared plus d plus 1 and q is 1 plus sin x whole square, right? Which is, okay, you can write this q as this is of a plus b whole square form, right? So let's expand this using the formula. A square plus b square plus 2ab is equals to 1 plus sin x whole square is sin square x plus 2 sin x. We know that cos 2 theta equals to 1 minus 2 sin square theta. Then you can just write this as 1 minus 2 sin square theta equals to cos 2 theta, right? Now, take this 2 sine square theta to RHS and bring this cos 2 theta to LHS. We'll get 1 minus cos 2 theta equals to 2 sine square theta. Now, bring this 2 to LHS. We'll get 1 by 2 into 1 minus cos 2 theta equals to sine square theta, right? Since sine square theta equals to 1 by 2 into 1 minus cos 2 theta, then for theta equals to x, we'll get sine square x equals to 1 by 2 into 1 minus cos 2x, right? Now, replace sine square x by 1 by 2 into 1 minus cos 2x, okay, plus third term remains the same, is equals to 1 plus 1 by 2 into 1 is 1 by 2 minus 1 by 2 into cos 2x is 1 by 2 cos 2x plus 2 sine x, right? Now, let's add these two numbers. Take the LCM. 2 will be your LCM. 2 into 1, 2 plus 1 by 2 is 3 by 2. This becomes 3 by 2 minus cos 2x by 2, or you can just write it as 1 by 2 into cos 2x. Okay, it will be more convenient. Plus 2 sine x. Now, we are having 1 plus sine x whole square is equals to 3 by 2 minus 1 by 2 into cos 2x plus 2 into sine x, right? Now we can replace q by these three terms. Will become yb becomes 1 by f of d into 3 by 2 minus 1 by 2 into cos 2x plus 2 sine x, right? Is equals to now we can write yp as 1 by f of d into first term minus 1 by f of d into second term 1 by 2 into cos 2x plus 1 by f of d into third term. So now we can write the first term as constant into 1 by d squared plus d plus 1 into, you have 1 here, right? We can write 1 as e power 0 into x, right? 1 can be written as e power 0, since e power 0 equals to 1, and also 0 into anything, say x is equals to 0, so we can replace 0 by 0 into x. So let's write or replace 1 by 0 into e power x for our convenience, because this will be of 1 by f of d into e power ax form. Minus constant into 1 by f of d, d square plus d plus 1 into cos 2x, which is of 1 by f of d into cos ax form, right? Plus constant 2 into 1 by d square plus d plus 1 into sine x. This is of 1 by f of d into sine ax form, right? Let's name each term under brackets. I'll name this one by yp1 and 1 by f of d into cos as yp2 and 1 by f of t into sine as yp3 for my convenience, right? Then this becomes 3 by 2 into yp1 minus 1 by 2 into yp2 plus 2 into yp3. Now we need to find yp1, yp2 and yp3 values or results of yp1, yp2 and yp3, we can say. So firstly we'll find yp1. We have yp1 equals to 1 by f of d into e power 0x. This of 1 by f of d into e power ax form for a equals to 0, right? We have f of d equals to d square plus d plus 1. So let's find f of a. For a equals to 0, we need to find f of 0. Just replace d by 0, then you get 0 square plus 0 plus 1, which is equals to 1, right? Which is non-zero. Since f of 0 is non-zero, so what we can do? We can just replace d by 0. We'll get 1 by 1 into e power 0x, which is equals to 1, right? Or 1 into e power 0, which is equals to 1 into 1, equals to 1. Denominator must be non-zero, right? We have to remember that the denominator must be always non-zero. What happens if you get denominator 0? We'll get the total yp1 becomes 1 by 0 into e power 0x. Since 1 by 0 is undefined, so total term becomes undefined if the denominator becomes 0. Fine. Now, let's find yp2. yp2 equals to 1 by f of d into cos 2x. d square plus d plus 1 into cos 2x is equals to this of 1 by f of d into cos ax form, right? Then for a equals to 2, we'll find d square, which is given by minus a square. Then for a equals to 2, we'll get minus 2 square is equals to minus 4. We should always remember that the denominator must be non-zero. So let's see what happens if we replace d square by minus 4 in the denominator. Replace d square by minus 4, then you will get minus 4 plus d plus 1, which is equals to minus 4 plus 1 is minus 3 plus d, which is equals to d minus 3 is non-zero, right? Since denominator becomes 0 by replacing d square by minus 4, so we can replace d square by minus 4, right? Then this becomes 1 by minus 4 plus d plus 1 into cos 2x, which is equals to 1 by minus 4 plus 1 is minus 3 plus d into cos 2x, or you can write it as 1 by d minus 3 into cos 2x. See, you're having minus sign between d and 3, or between first term and the second term, right? So let's change this sign. If we change this sign, we'll get d plus 3, right? So we need to multiply and divide by d plus 3 to this fraction into cos 2x gives d plus 3 by d plus 3 into d minus 3 into cos 2x. This becomes d plus 3 by, in the denominator you are having d plus 3 into d minus 3, which is of a plus b into a minus b. You can write it as d square minus 3 square, since a plus b into a minus b is equals to a square minus b square, right, into cos 2x is equals to d plus 3 by d square minus 3 square is 9 into cos 2x. See, again d square appears in the denominator, so what we have to do, we have to check what happens if we replace d square by minus 4. Take the denominator part and replace d square by minus 4. You'll get minus 4 minus 9 is minus 30, which is non-zero, right? The denominator is non-zero by replacing d square by minus 4. So we can replace d square by minus 4. And this becomes d plus 3 by minus 4 minus 9 into cos 2x, which is equals to d plus 3 by minus 4 minus 9 is minus 13 into cos 2x, right? Again, you can write this as 1 by minus 13 into d plus 3 into cos 2x. Let's write 1 by minus 13 as minus 1 by 13. Okay. We'll write 1 by minus 13 as minus 1 by 13 into d cos 2x plus 3 cos 2x. Here d is a differential operator, so what we have to do? We need to find derivative of cos 2x with respect to x in the first term plus 3 cos 2x, which is equals to minus 1 by 13 into derivative of cos 2x is minus 2 sin 2x plus this term remains the same, right? Now, just look at yp. In the second term, you are having minus 1 by 2 into yp2, right? You are having already minus 1 by 2. So here, we don't need to multiply these two terms with minus 1, because this minus and this minus becomes minus into minus, which is plus, right? So we'll just leave this minus as it is here, and we'll write this as, firstly write the term involving plus sign and then term involving minus sign. Okay. Or you can just multiply these two terms with this minus, and again you might need to change in yp2 after replacing the result obtained from yp2 in yp. So this is a result obtained from yp2. Therefore, yp2 equals to minus 1 by 13 into 3 cos 2x minus 2 sin 2x. Now let's find yp3. yp3 is 1 by f of t into sin x. This of 1 by f of d into sin ax form. For a equals to 1, we'll find d square, which is given by minus a square. That is minus 1 square for a equals to 1. Just compare sin x with sin ax, and you'll get a equals to 1. So the value of d square is minus 1 here. Always remember, the denominator must be non-zero, right? Now let's see what happens if we replace d square by minus 1 in the denominator. I'll just take the total fraction here to show you. 1 by d square can be replaced by minus 1 plus d plus 1. Here minus 1 plus 1 gets cancelled and you get 1 by d, which is non-zero. Or just take the denominator part and see what happens. You'll get d, non-zero, right? Denominator becomes non-zero here. So the denominator will not become 0 by replacing d squared by minus 1. So what we can do here? We can just replace d squared by minus 1. Then yp3 becomes 1 by minus 1 plus d plus 1 into sin x equals to 1 by minus 1 plus 1 gets cancelled and you'll get 1 by d into sin x. If d is a differential operator, then 1 by d is inverse of differential operator, or you can just call it as integral operator. So now we need to find integral of sin x. Integral sin x is minus cos x. So therefore, result obtained from yp3 is minus cos x. Now coming to yp becomes, result obtained from yp1 is 1 minus 1 by 2 into result obtained from yp2 is minus 1 by 13 into 3 cos 2x minus 2 sin 2x plus 2 into result obtained from yp3 is minus cos x. Then yp becomes 3 by 2 minus into minus plus 1 by 2 into 13 is 26 into 3 cos 2x minus 2 sin 2x plus into minus minus 2 cos x is our yp. Now we can write the general solution. Therefore the general solution is given by y equals to yc plus yp, right? Then y equals to, we have yc e power minus x by 2 into c1 cos x root 3 by 2 plus c2 sin x root 3 by 2 plus yp plus 3 by 2 plus 1 by 26 into 3 cos 2x minus 2 sin 2x minus 2 cos x. This completes the problem. Therefore, y equals to e power minus x by 2 into c1 cos x root 3 by 2 plus c2 sin x root 3 by 2 plus 3 by 2 plus 1 by 26 into 3 cos 2x minus 2 sin 2x minus 2 cos x is the required solution. So we have seen a problem in this video from higher order linear differential equations. Hope you'll understand. We'll see you in the next video. Until then, bye bye.